This is lesson 9.2, and we're going to be learning about lines of best fit. A line of best fit, or a line of fit, is a line drawn on a scatter plot close to most of the data points, and it can be used to estimate data on a graph. So we're going to be taking a look at an example, and then we'll be drawing a line of best fit. So in this example, the table to the left shows the depth of a river X months after a monsoon season ends. So A, we're going to make a scatter plot of the data, then we'll draw a line of fit. B, we'll write an equation for that line. C, we'll interpret the slope and the y-intercept. And then D, we'll predict the depth in 9 months. So again, just use a graph table, draw it. Usually quadrant 1 is all you need. Plot the points, okay? The scatter plot does show a negative linear relationship, so we're going to draw a line that is close to the data points. Try to have as many points above the line as below the line. And what you'll see is that you can calculate the slope, and you can calculate the slope using, say, 2 of the points. So what they did is they kind of looked right here and they decided to use these 2 points to calculate the slope, okay? Right here you can see those 2 points on the line. So when you use those 2 points, you get a slope of a -2. You look to see where it crosses the y-axis because that is your y-intercept. So your line of best fit has an equation that could be approximately -2x plus 20. To interpret the slope, it is -2 and the y-intercept of 20. So the depth of the river is 20 feet at the end of the monsoon season and decreases about 2 feet per month. So that's what that tells us. To predict the depth in 9 months, we want to substitute in the 9 for x and calculate that in about 9 months we should see it at about 2 feet. Okay, the depth should be 2 feet. Now, notice this study tip right here. It says a line of fit does not need to pass through any of the data points. It's just a coincidence that this one does. And you can use the information that you plot to calculate the slope. Okay, so let's give this a try. So we will be plotting these points. Okay, we need to make a graph, a scatter plot, and it's going to be the number of people who attended a festival over an 8-year period. So the y-axis is the attendance or number of people. On the x-axis, it is the years. Okay, so we can count years, 2, 3. So we're an 8-year period. We could count probably by 400. Let's go up by 200 each time, maybe. That gives us enough places. Yeah. So 400, so 600. I won't put all of these on here. I'll just skip a line, I guess. So the first one will be 400. It'll be 6, so then this will be 800. This would be 1,000, so this would be 1,200. 14, 16, 2,000, and the last one is the 2,400, so that'll fit all of our points. So we had about 420 the first year, and then you had about 500 in year 2. In year 3, it's about 650. Year 4, it's about 900. Year 5, you had 1,100. Year 6 was 1,500. Year 7, 1,750. Year 8, you have the 2,400. Okay. So if we're going to draw a line of best fit, we need some points below and some points above the line. And obviously we don't have the same number above and below the line. I could have probably, maybe if I redraw it, let me redraw it in a different color. It's really hard for me to do, and you'll be able to use a ruler, so you'll be able to see a little bit better. So maybe, and that's not even straight. Okay, so we could have a couple points above, couple points below the line, again, to try to make it a line of best fit. But we can see that this is a positive linear correlation, that the longer the festival is going, I guess word of mouth, people attend it, you know, they enjoy it, so they tell people. So we're going to use a couple points, you know, let's maybe like use these 2 points right here to calculate the slope. We're going to have to get the slope. So we'll have 900, and you could use any 2 points, but I just picked some in the middle. Okay, over 4 minus 3. So I get about, say, 250. So y would be equal to, in this case, 250 would be my slope. And note that in this type of a situation, what fits the context of the problem is that no people attended, you know, this festival when it didn't exist. So this makes it a, right here, so that we have a y is equal to 250x because our y-intercept is equal to 0. So that's A, we did our scatter plot, we wrote our equation. To interpret the slope in this case, you know, the fact that we have, there is, you know, okay, so the y-intercept of 0 means that before the festival started, there was, you know, no attendance. So prior to the 8-year festival was 0. And the slope shows that we're increasing by about 250 per year. That's kind of our average increase. So that if we had to find out how many people or predict the number of people that might attend, so, you know, they might look at this data because now they're, you know, you have people coming in with food and you have entertainment, you have to figure out the number of people that you're going to be, you know, having at this festival to make sure you have enough of everything you need. So in year 10, we could say that y would be equal to 250 times that 10, and we could anticipate about 2,500 people in attendance in year 10. So that just kind of demonstrates and shows you all the steps to answer all the questions for this type of problem.